when you use your TI 84 or 83 calculator and plot functions, either linear functions or functions that involve quadratics or cubics, you can find the points of intersection of the curves by using a feature on the calculator called Intersect. And I'm going to create two functions on this calculator and graph them, and then we're going to look at the points of intersection using the Intersect feature. So first, I always put myself into standard zoom before I graph anything, which is a 10 by 10 graph. It's negative 10 to positive 10 on the x, negative 10 to positive 10 on the y, and then press y equals. And I'm going to graph the absolute value function shifted. So second math, it's not second math, it's just math num ABS. Okay, I'm going to plot the absolute value of x minus 3, which is the absolute value graph shifted 3 units right, and the horizontal line y equals 6. So these are two functions, one linear, the other one's the absolute value function, and we're going to hit graph. And you can see that there's a point of intersection here, and there's another point of intersection on the right of the graph right here. Now, algebraically, you can solve for the points of intersection, but I'm going to show you how to also check that point of intersection using the calculator. Now, you already know that the ordered pair has a y, whatever the ordered pair ends up being at either point of intersection, the y coordinate is going to be 6, because the horizontal line shows us that all points on this horizontal line have a y coordinate of 6. To find out what the x coordinate is, we can use the intersect feature. So we hit second, calc, and we move down to option number 5, intersect, enter. Now, the place where the cursor is flashing is a starting point. The point of intersection closest to that starting point happens to be the point of intersection on the left. So when we first run this intersect feature, it's going to find the intersection on the left. The question at the bottom of the screen asks you to basically identify what the first curve is. Now, the word curve is a little misleading because ours is an absolute value function that we're currently flashing the cursor on. So it really should be like the first function. What's the first function? And we can say enter, meaning that the first function can be the absolute value function. Okay. Now it's asking you for the second curve or the second function, and now it's flashing on the horizontal line y equals 6, so we'll hit enter on that second function, and then it's saying guess. Now if we move our cursor close to the point of intersection, it's going to calculate the point of intersection here on the left. If we move our cursor closer to the point of intersection on the right, it's going to try to find this point of intersection. But let's do the one on the left first. So I'm going to move in the proximity of this point of intersection and hit enter. Okay, the point of intersection is -3, 6. We already knew that the ordered pair was going to have a y coordinate of 6. It has an x coordinate of -3. So if you were to ask to solve the equation, absolute value of x minus 3 equals 6, one of the solutions would be x equals -3. To do this for the other location, the other point of intersection, we run through the same set of options. Intersect, enter. It asks you for the first curve, so let's make sure we're flashing on the absolute value function, hit enter. Second curve, we're on the linear, the line, press enter. And guess, let's move our cursor in the proximity of the other point of intersection. We want to be close to that other point of intersection, and we'll hit enter again. And the intersection there is 9, 6. So the other solution to the equation, absolute value of x minus 3 equals 6, would be 9. So the two solutions are -3 and 9. And that's how you solve points of intersection on the calculator. You could do this with any number of functions.